Hello everyone, welcome to my channel. So today we will learn about Brillouin zone. So in the real space we have XYZ, but if we represented it in reciprocal space, it is written as Kx, Ky, Kz if we simply do the Fourier transform. So Brillouin zone is actually called as the Wigner seed cell of reciprocal lattice. But this term actually used for real space. What is more technical term is Brillouin zone. So like the unit cell is the smallest thing in real space which repeats itself. It is the Brillouin zone which we use in reciprocal space or lattices. So first of all we need to know what is Wigner seed cell. So what is the definition? Definition is it is constructed by first drawing lines connecting a lattice point to all the neighboring points in the lattice. So you take one lattice point and then you connect all the neighboring points to that lattice and then bisect each line which you have drawn with a plane that is known as Bragg plane. So that perpendicular bisector is actually known as Bragg plane, normal to this line. For example, I am using a 2D. Here you can see 2D 5 cross 5 thing. So I have written 5. I have taken 5 points here. So 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5. I'm not talking about 3D right now, it is only 2D because it is easy to understand. So suppose we take a center. Center is actually origin. You can write origin of reciprocal space. So you have origin, and from that origin you connect all the neighboring points. Okay, so what are the neighboring points? So you have a lattice like this. So what are the nearest neighboring point, lattice point? So I think this one is the nearest. Okay, and then this one is the nearest. Okay, then this one is the nearest, and then this. So these four are the nearest. Now by our definition we draw a line joining all these neighboring points. So this lattice point is joined by this line here, and this line also, this is also neighboring point, closest neighboring point. This point which is very close to this lattice point, and then this line. Now we need, because this is the line, this is actually the dotted line, these are the nearest neighboring point. So if we first connect this point, this is the origin, this is the origin, and by the origin which is the lattice point we are talking about, and we connect all the nearest neighbor lattice point by a line. Now we need to draw the perpendicular bisector. So these are the perpendicular bisector, and this is known as Bragg plane. So this is the perpendicular bisector for this line. This is the perpendicular bisector. This is the second Bragg plane of this line. This is the perpendicular bisector of this line, and this is the perpendicular bisector of this line joining this lattice point to this. If you draw it neatly, it will look like a square. Okay, so this is square, these are the boundaries, and this cell is known as the Wigner seed cell. It is the region which is very close to the lattice point we are talking about, and this is actually this region. This is the Wigner seed cell about this lattice point. We are talking about the origin here. So this is also known as the first Brillouin zone. So we are only talking about the Bragg plane. These are the boundaries. These are the perpendicular bisector, and the perpendicular bisectors are known as the Bragg plane. So can you define what is the second Brillouin zone? So second Brillouin zone is, again, you talk about the next closest neighboring point. So suppose we are talking about this and this for the first Brillouin zone, then what about this? This is the second nearest neighboring point. This is the second nearest neighboring point, this point and this point. So we connect this point to this point by a line, this point to this point by a line. That is our definition of our Wigner size cell now. So this line to this line. So now we draw the perpendicular bisector like this for this joining of line, and then perpendicular bisector for this line, and again the perpendicular bisector for this line. This is the perpendicular bisector. Okay, so we have done it like that, and this is actually our second Brillouin zone, in which we are taking the next closest lattice point. In the similar way, you can define the third Brillouin zone. So if you like this video, please like, share and subscribe my channel. Thank you.